All right, welcome back to my dining room and slash lecture hall. And I did want to do a short lecture on nomenclature of complex ions and coordination compounds. So here we go. All right, so just like naming regular ionic compounds, we'll name the cation first and then the anion. Now, the complex ions, in the complex ions, so we may have a complex cation, let's say. We want to name the ligands first and then the metal ion. So in complex ion, name ligands, then metal. All right. Now for ligands, there are certain rules. And so typically we will add the suffix O to the root of the anion name. So an example could be, so for example, Cl is chloro, and so Br would be bromo, etc. Now there are some particular names for some ligands that you should be familiar with, that you should know. And these are ones for neutral molecules. So use molecule name for neutral molecules. And so let's say we had what's a good example here? Let's say we had methylamine, so CH3NH2. That would simply be methylamine. Other examples are ethylene diamine that I mentioned last time. And you just name the molecule. Now there are some special names. So others have some special names. Some neutral ligands have special and we'll go ahead and take a look at what those names are in just a minute. But you can go ahead and pause and copy this down. Although I will say that these rules are in the textbook. So you can take a look in chapter 21. I believe it's section 21.3. Yes, 21.3. End of section 21.3. Let me just write that down here. Section 21.3. All right. Okay, now that you're done pausing and copying things down, we'll go ahead and erase. And take a look at some of those special names. So water is aqua. Ammonia is amine with 2 M's. I know, it's weird. That's just crazy inorganic chemists. CO, carbon monoxide, is carbonyl. And NO, nitrogen monoxide, is nitrosyl. So these are ones that you should know. And after you figure out what the names of your your ligands are, you've got your names of your ligands, you'll use prefixes to indicate how many of them there are. So use numeric prefixes to indicate number of each ligand. And so in this case, you know, if we had 1, that's mono, 2 is di, 3 is tri, 4 is tetra, etc. For more complicated ligands, we actually have some different numeric prefixes that we use. So I'm going to say complicated ligands use, and we'll still use mono, but 2 will be bis, 3 is tris, and 4 is tetrachus. Typically we don't have more than 4 complicated ions. Now what do I mean by complicated ligands? So what do I mean by complicated ligands? Well, if your ligand name has a di or a tri in it, like ethylene diamine, then you don't want to use di again, diethylene diamine. What does that mean? Does it mean I've got 2 ethylenes in my structure? Does it mean I have 2 ethylene diamines? But if you use bis, and say bis ethylene diamine, then it's not as ambiguous. So we could take a look at some examples here. I'm just going to erase again. And so let's look at some examples. So let's do Cu and CuNH3, do 4 of those, Cl2. Another one, maybe we'll do cobalt, CO, and En, and then H2O 4 Br3. Okay, so again, we name the anion first. So in this case, it's copper, and we've got 4 amines. But although I wrote the copper first, we actually named the ligands first. So this becomes tetraamine copper, and it's going to be copper chloride because I've got chloride as my counter ion. I've got 2 of them, so my copper has to be +2. So this is tetraamine copper 2. We'll use the Roman numerals there. Chloride. Now, in this case, we've got an ethylene diamine and 4 waters. Let me change that actually. I'm going to change that so we can use a bis here. Let's just do 2 waters, and we'll do 2 ethylene diamines and 2 waters. There we go. So we would call this, and we'd name these in alphabetical order. So we have diaqua, bis ethylene diamine, bis ethylene diamine. And you can put it in parentheses like I did. That really kind of sets it apart so that, excuse me, so that you know what the bis is referring to. And then of course we have cobalt. And it's cobalt-3 because we have 3 minus charges from the 3 negative charges from the bromines there. So that would be diaqua bis ethylene diamine cobalt-3 bromide. Phew, say that 3 times fast. All right, just a couple more things to mention, or maybe just one more thing to mention. If the complex ion has a negative charge, then we give it the suffix -ate. So complex ions with negative charge so we'll name it, but we'll have a suffix of -ate. So for example, let's say we had the following: K2 PTCl4, like that. Now, again, we name the cation first. The cation here is potassium. So this becomes potassium, okay, because that's our cation. And then this complex ion here is PTCl4 with a 2 minus charge. So we would call this tetrachloroplatinate. Potassium tetrachloroplatinate. Now we still have to indicate the charge on the platinum, the oxidation state of the platinum. If this ion is -2 overall, 2 minus overall, and there are 4 negative charges and chlorines, then 2 of those are offset by the platinum, so it's platinum 2. So we would just stick the Roman numeral at the end of the name, I think, is the easiest way to do it. So this is nomenclature of complex ions. I don't think I'm going to specifically quiz you on these. Maybe I will. Maybe the first online quiz that we have, I'll have some naming type questions on it, and we'll go from there. But I tend not to ask too many specific nomenclature questions. But you should know the rules of nomenclature in case I give you a name, tetraamine copper 2 chloride. You should be able to draw what the structure is. All right. So next time we'll talk about some actual structures, and I'll have some more models to show you guys. But until then, I'll talk to you later.